Martin, do you think you could pick up the quizzes for me? All right, guys, so Trig Identity Review, Worksheet 1. On the quiz, the learning targets will be, can you find trig values given other trig values, which is not anything new. Then, can you simplify expressions using trig trades? That's not really new, but it's new right now. And then even and odd functions. All right, you should have out your reference sheet. Okay? The blue cardstocky one. Are we ready? Okay. An identity is simply an equation if the left side is equal to the right side for all values of x for which both sides are defined. So this one has a restriction, x cannot equal 3, but otherwise it's true. This one, sine x equals 1 minus cosine x, is only equal a few places, okay? So it's not an identity. Here are some trig identities that involve trig functions, okay? You know a few of these basic ones, like sine is the reciprocal of cosine, etc., okay? Here, tangent equals sine over cosine, or cotangent equals cosine over sine. We did not put these on the reference sheet because these are the ones you're already supposed to have memorized. Any questions? All right, real quick, this is an important concept. When we write sine squared of theta, it really means the sine of theta squared or sine times sine. Oops. Okay. It's just shorthand, we square the function. It is not the theta that is squared. It is the whole function. Any questions about that? Everybody's comfortable with that notation? All right, so there is a Pythagorean identity that says sine squared plus cosine squared equals 1. It is the foundation of the whole unit circle. All right, because the unit circle means it has a radius of 1. So this is basically saying all the y values squared plus all the x values squared equals 1 at any one ordered pair, okay? Sine squared plus cosine squared equals 1. This one you really should have memorized. We did go ahead and put the Pythagorean identities on the blue sheet, but only in the most basic form. All right, the second one, or any of the other two, let's see. If I were to divide this basic one all by sine squared, what's sine squared over sine squared, guys? 1. What is cosine squared over sine squared? Well, what's cosine over sine? Cotangent. And 1 over sine squared? Cosecant squared, yes. So unfortunately, I developed this one, not this one. Okay? All right. Now, I developed it by dividing all them by sine squared. What else could I divide them all by? Okay, so if I divide them all by cosine squared, sine squared over cosine squared is tangent squared. You need to know this. Cosine squared over cosine squared is 1. What's the reciprocal of cosine? Okay, so that's this guy. So if you only had this one memorized and you knew all the definitions, you could develop the other two, but we did put them on the reference sheet. The problem is we did not put any of the other versions of them, okay? For example, you can take this one and subtract the cosine squared from both sides and you will have this one. Does that make sense, everybody? Or you could subtract a sine squared from both sides and have this one. Guess what else you could do to those? 1 minus cosine squared, is that the difference of two squares? So it could factor 1 minus cosine times 1 plus cosine. Everybody see that? That would be 1 minus cosine squared if you foiled it back together. So this would equal sine squared, etc. Okay? Now, all of them can be rearranged, and you have to be comfortable with that. So anytime you see squared quantities, you need to think, I'm looking for Pythagorean identities. If there's adding and subtracting going on, okay? If they're just multiplied times other squared quantities, that doesn't necessarily mean it's a Pythagorean identity. So again, here's a whole bunch of ways you could rearrange these, but these are not on your reference sheet. You need to be able to rearrange them. Okay. The first few questions today are just about drawing in the right quadrant. You can use trig identities to solve for these, but I never do. This says you're between 0 and 90, so you're in quadrant 1. The sine, which is opposite over hypotenuse. Can you find this side, guys? 3 squared plus something squared equals 5 squared. So it's 4. So the tangent from this angle, anybody? Opposite over adjacent, 3/4. Okay, this is not new. All right, these are beyond easy. If you know the cotangent, how do you find the tangent? If you know the sine, how do you find the cosecant? So this should be any question on those? All right, this one has a negative cotangent. All students take calculus. Well, the tangent and cotangent are positive here and here, so it can't be in either of those quadrants. What does this mean? The sign is, oh, I'm so frustrated that some of you still don't know. That is a less than 0, which means it is negative. Where is the sign negative? Yes. So we are in quadrant 4. This is true. How do you label cotangent? It's adjacent over opposite, because tangent is opposite over adjacent. So from this angle, adjacent is 4, opposite is 3. Which one gets the negative, though? Because you went down, okay? Then if you do Pythagorean theorem, you had better come up with a 5. I got people who still are doing Pythagorean theorem wrong. Okay, cosine is adjacent over hypotenuse. Cosecant would be hypotenuse over opposite. I think I did those right. Anybody disagreeing? Any questions? Do we need to do another one? Maybe at least figure out what quadrant this is. All students take calculus. Secant is negative, so that means what else is negative? Okay, they want the cosine. Well, we don't need to do any work, do we? That would be negative 1/4, because it just flips over. But where is the cosine negative? One of these guys? Okay, cosecant is positive, which means sine is also positive, so it's in quadrant 2. All right, the secant is negative 4/1, so hypotenuse, can I put a negative 4 on the hypotenuse? No, hypotenuse is always positive. Cosine would be negative 1 here. When I do Pythagorean theorem, I get square root of 15, because it's y squared plus negative 1 squared equals 4 squared. So this is just 1. So y squared equals 15. Square root of 15. It's got to be smaller than 16, right? Because 16 is the hypotenuse squared. All right. Does that need a negative? not for the quadrant we're in. So tangent would be opposite over adjacent, or negative square root of 15 over 1, or just negative square root of 15. Any questions on sine, cosine, tangent, drawing, all that fun? All right, the second thing it talks about are, I believe, the even and odd functions. By definition, if a function is odd, then you can get rid of the negative because it is the same whether you go left or right. If a function is even, if you go left versus right, no, I just said that backwards. If it's even, then you can get rid of the negative because it's the same on both sides, right? This is an even function, guys. So if I said go left or go right, you're going to hit the same value. If it is an odd function, like this, it is going to have the opposite sign. So if I say go left or go right, the same amount, you will hit the same value, okay? But it's going to have the opposite sign. So you have this chart. We're not taking it away from you. Does everybody see where this is right here on your reference sheet? It's on the right side. It says even odd identities, okay? So if a function is odd, the negative can go from inside to outside. If a function is even, like these are even, the negative can just be thrown away. Any questions about that? Co-functions, we did not talk a lot about this yet, but the sine and cosine, just think about this for a minute. If this is a 90-degree angle, and I know the sine of this one, which would be opposite over hypotenuse, from this one, that is the cosine, right? Because it would be adjacent over hypotenuse. It's called co-functions because of the complement. So the sine of A is equal to cosine of B or the complement of A. So, for example, these are all just in radians. All right, these are on the reference sheet. Does everybody see them on the reference sheet? Co-identities. We're not going to use these until later when we do sum and differences, so I'm going to skip all this. All right, so when you get to this part where you have to simplify and rewrite trig expressions, you can use your whole toolbox of things. You can use substitution, factoring, simplifying fractions, rewriting. We usually encourage students to rewrite in terms of sines and cosines, as most of us don't like secants, cosecants, etc. Use identities to trade or simplify. If there's any squareds and addition in there or subtraction, look for Pythagorean identities. Unfortunately, you may need to use some factoring, or even more unfortunately, you may need to get a common denominator, which is not everybody's favorite. And you can use a conjugate if a fraction is not wanted. For example, if you had 1 minus cosine, what is the conjugate of that, guys? 1 plus cosine over 1 plus cosine. Remember, the conjugate means you change the sign in the middle. Then when I FOILed the bottom together, what would I get? 1 minus cosine times 1 plus cosine would be 1 minus cosine squared, because when you FOILed it together, you'd have a negative cosine, a positive cosine that would cancel each other out. And what is 1 minus the cosine squared? Anybody know? It is sine squared. All right, now on the top, you'd still have this, but maybe that's what you were trying to get to. I don't know. All right, here we go. I don't know if this one's done for you, but it says cosecant, which I can trade for a 1 over sine. Cotangent squared, maybe you don't even have this example. It's on the back, okay. Cotangent squared. Do not trade that for 1 over tangent squared, okay? Cosine squared, or I'm sorry, cotangent squared is cosine over sine for cotangent, and then you could square each of them, or I usually just square each one separately. You could put a big parentheses around and say it's squared. And then this one says plus, so be careful. You can't cancel anything when it's being added. So what kind of a mess do I have right here when I multiply these together? This becomes just a cosine squared. What can I do down here? I have a, what's a sine times a sine squared? A sine cubed. Well, that helped a lot. Now what? Ideas? To be able to combine these, we need to have a common denominator. What should our denominator be? Sine cubed. So this one I would need to multiply by a sine squared over a sine squared. Please show your steps. So I'd have a cosine squared plus, what does this become? A sine squared. And the denominator for both is now sine cubed. All right, what is cosine squared plus sine squared? It's a 1 you should have memorized. The 1 you should have memorized. It's 1. Cosine squared plus sine squared is 1. Okay, this is a Pythagorean identity. So we have 1 over sine cubed. What is a 1 over sine, guys? So I could also write this cosecant cubed. Now, I would probably accept if you left it right there, okay? Unless it said otherwise. That's the difference between today's lesson and tomorrow's lesson. Tomorrow's lesson is proofs, so I tell you where to stop. Today, it's kind of up in the air. Am I finished? Did I simplify enough? Yeah, I'm not as big a fan. Sometimes these are very easy. They simplify down to something very straightforward. A lot of times I'm like, am I done? All right, so let's try this one. Number 6. What do you want to do first? Okay, so you want to leave the cosine of x and change this to what? Tangent is? And cotangent is? By the way, I'm not one of those picky teachers. If you lose your x's along the way and then just throw them back on your answer, I'll live with it, okay? It is proper only if you have the x's on, or the theta or whatever it is on every part of it, but I lose them all the time when I'm in a hurry, so. If we distribute this, what happens when we multiply cosine times sine over cosine? We just get sine x because the cosines cancel. Okay, and when I multiply back here, cosine times cosine over sine, I get cosine squared, because this is just over 1 over sine. Any ideas? Can I cancel these signs? Only if it's multiply, right? Cannot cancel across a multiplication, addition or subtraction. What can I do instead? Yes, sine x over sine x. So now I have a common denominator of sine x. What did this become? A sine squared plus a cosine squared, which is a 1 over sine x, or so lots of getting common denominators. Anybody have a question? All right, number 7. Ooh, I'm scared. Can I cancel the tangent? Unfortunately, no, because the top has glue, right? That plus sign is gluing things together up there. I honestly don't know the best way to start this one. I'm thinking maybe sines and cosines, and we'll see what happens. What is tangent? Sine x over cosine x plus, this is a sine x, so sine x over 1 if you gave it a denominator, times what is secant? Oh. So now this is really back here just a sine over cosine, same as this one, right? All right, but let's keep going right in the denominator. What is cosecant? 1 over sine x, and tangent is? Okay, so the top, maybe I'll show, since it's notes, I'll show a little work, but it's a sine x over a cosine x plus this back parenthesis back here becomes another sine x over cosine x, right? So we have two of those. What happens in the denominator though? So we have that this is being divided by 1 over cosine. All right, so you want to add the tops together and we get what? Okay. Yes, we have a 2 sine x cosine x, and you can write the 2 on the top, or you can write it out in front. It doesn't matter. It is a 2 over 1 if you're thinking of it that way. Then that, I'm going to write now as a divide, is being divided by 1 over cosine, because what do you do when you divide? Multiply by the reciprocal, so this will become times cosine over 1, which is 2 sine of x. You do not get good at these by watching someone else do them. You have to struggle and try them and see what happens, because you're never going to know how to attack them if you don't practice. All right. I'm looking at this one, and I could be wrong, totally. But do we have a Pythagorean identity that maybe could trade for this? 1 plus tangent squared? 1 plus tangent squared is a secant squared? Okay, and the numerator is a cosecant squared. So now what do you want to do? Okay, so this is really a 1 over sine squared that is being divided by a, what is secant? Can you finish that? Which one do you flip over? The second one. Yes, it is a cosine squared over a sine squared now, which is a cotangent squared. Okay, until you have those basic trades memorized, like you know down cold that cosine over sine is cotangent, it's just going to feel like I'm doing magic, okay? You got to memorize the basic ones. The ones that aren't on the reference sheet. Any questions? All right. Ugh. What do we have to do here? We could. Do you want to FOIL it first, or do you want to trade it all first? I don't know what's a better plan. You want to trade it first? Okay. 1 over cosine minus, what is tangent? Sine over cosine. Oh, well, the good news is that parenthesis has what then? Common denominator in that parenthesis? Okay, what about this second parenthesis back here? Cosecant is 1 over sine, and then right now it just says plus 1. What can this first parenthesis become?
1 minus sine x
All over a cosine of x times, what could we do back here? If we want to combine that, we need a common denominator of what? So we could rewrite 1 as sine x over sine x, and then what would the top become? 1 plus sine x all over sine x. Okay, now what? I don't have any divide. Flipping it would not be a good plan. Yeah, if we FOIL this, we get 1 plus a sine x and then a minus sine x, which would cancel, and then it's a minus sine squared. What is the denominator? It's not cotangent, be careful. It's cosine times sine, right? Okay. I see a plus minus with a squared. Any trig identity trades we can do for Pythagorean theorem on the top? This is a Pythagorean identity. Okay, if cosine squared plus sine squared is 1, then 1 minus the sine squared would be cosine squared. And the denominator has a cosine and a sine. So what will divide out? One of the cosines, then I'm left with a what? Just a single cosine over sine, which is a could have totally done that in a different order. We could have FOILed it together first. Lots of different ways to attack these. Only in further math, probably. But the idea of trading out for equivalent quantities is all over the place. And last I knew, there was one of these questions on the placement test for University of Illinois at Chicago, and you had to have the identities memorized. And I'm not saying you're going to get every question right on a placement test, right? But it was on there. All right, is this a Pythagorean identity, guys? Cotangent squared plus 1? That is a cosecant squared. Secant squared minus 1 is another Pythagorean one, right? We'd have a tangent squared. Okay. So now what? Maybe back to sines and cosines. What is cosecant squared? Tangent squared is a sine squared over cosine squared. So what happens? Because we're multiply, we can cancel or divide those out. Get 1 over cosine squared, which is a secant squared. Everybody good? Oh. What do you want to do here? Is it tangent squared? You guys tell me, do you want to get a common denominator or you want to trade something out? This is what we have. We have 2 terms added together. But can't we trade a tangent squared for a what, guys? Nah, I don't think I want to go there. I don't think I want to do sines and cosines if I can help it. Tangent squared is a secant squared minus 1, right? Anybody see why that might be a good idea? What did I say we could do with this? Does it factor?
Yeah.
Secant of x minus 1 and secant of x plus 1, right? So I have a 1 plus secant of x minus 1 times secant of x plus 1 all over 1 plus secant of x is secant of x plus, oh, yeah, I wrote sex, nice. Okay, secant of x plus 1 and 1 plus secant of x, is that the same thing? Yes, it is. Now what? 1 plus secant of x minus 1. Sounds a lot like, what? It's not a squared though. It's just a secant. Can't 1 plus and minus 1 plus and minus, we just have secant of x, but it's not squared. So we can't trade it for anything, it's just a secant. We could have done that clear difference. I just noticed that the top was a trade that would factor. I don't know if you have homework like this one, but can anybody figure out what the trade is for that just basically by looking at the reference sheet? Yeah, that's just a sine of x. Oh, divided by a, what is a cosecant? 1 over sine of x plus a cosine squared. What happens when you have a sine x divided by 1 over sine? When you change it to the reciprocal, you get, right? When you divide by, do you need me to rewrite that differently? It is a sine x being divided by a 1 over sine x, which means it's a sine x times the reciprocal. What's that going to simplify to, guys? A sine squared of x plus a cosine squared of x is 1. So that was really nice. I'll simplify down to just 1. Should I leave you to try the last couple, or you got this? What's a 1 plus tangent squared? So it is a cosine of x times a secant squared of x. What is a secant squared?
1 over.
So a secant squared is a 1 over cosine squared. What happens then? We can divide out one of the cosines, but we still have what? Which is, I think when they use secant, they should use theta. Less chance I'm going to write sex on the board, right? All right. Are we done? Oh, okay. We got some fraction fun. How do you want to try this? Want to try sines and cosines? What would cotangent be? Cosine over sine. And it is all divided by a secant would be 1 over cosine minus a tangent, which is now what? What can we do on the bottom? Don't they already have a common denominator? So the top is cosine x over sine x. It is being divided by, and I'm going to write it that way, we can combine this guy down here into 1 minus sine x over a cosine of x, because they had a common denominator. And what do you do when that happens? Yeah, you flip the second one over. Yeah, that didn't do anything nice, did it? Did I do something wrong, or?
You can make 1 minus cosine into cosine squared.
No, you can't, because it's not squared. But I think you're on the right track. I think that's a good thing to be thinking about, because what is this top? Cosine squared. This is probably the way long way to do this, I don't know. We have in the denominator a sine and a 1 minus sine. We could FOIL that together, but what could we trade cosine squared for? 1 minus sine squared, right? So if we had a 1 minus sine squared on the top, we don't have a 1 minus sine squared on the bottom. Can I cancel the 1 and the sine? No, they're glued together, but what could I do to that top? I'm sure this is the long way. Can I factor it? It factors what?
1 plus sine
I don't know where I'm going with this. What can cancel now? This quantity.
and then you change it back.
So now I have 1 plus sine x over sine x. Is this what we started with?
No, I don't think we've been here before.
Okay. How can we rewrite that as two separate fractions, right? If you have a plus b over 2, it's the same as a over 2 plus b over 2. Is everybody okay? So we could rewrite this as 1 over sine x plus sine x over sine x, guys? Yes? Separate it. And 1 over sine is cosecant of x, and this is a plus. Didn't they just say get rid of it so it doesn't have a fraction?
Felt that.
Okay, I think what we probably should have done way back up here was multiply through by the common denominator. What is the common denominator? Cosine times sine? So if I had multiplied the top by a cosine times a sine, and the bottom by a cosine times a sine, let me show you what happens, okay? Here on the top, these would divide out, and we'd get a what? Cosine squared. In the denominator, if I multiply this cosine sine times this, cosine will cancel, and I'll get, no, just sine. Here, when I multiply this, cosine will cancel, and I'll get a minus sine times sine, which is, okay. The denominator, I could have factored out a sine. Nope.
Cosine.
Cosine, nope. It's equivalent to this step right here, right? Is that getting, we still would have had to do all this, I think. So it wasn't any, ugh. Okay, yep, that was not a fun one. Last one, rewrite in terms of a single trig function. So everything should go away until we have one function. But do you want to leave cosine just like it is for a minute? What do you want to do to tangent? And that's being multiplied by a sine, then what? If you combine the right side into a single fraction, you have sine squared over cosine. So what do we probably need to do to the left side? Multiply it by cosine over cosine so that we have what? Cosine squared over cosine, because now we have a common denominator. We end up with a cosine squared plus a sine squared all over the common denominator of cosine, and cosine squared plus sine squared is 1. We still have 1 over cosine, which is a,
That was so much simpler.
all right. I think we just did way more than is even assigned, okay? Assigned are these questions. The book work is in the back. That's 9 questions, I think. Okay? Please practice